So the story begins here in the front office. I was using my Atari ST and I just made a video on how to attach a USB port, well I guess a USB micro lead rather than a port, to your Atari ST so you could power things like your Satan disk. And that was all very well and good, but then I turned my Atari ST upside down to plug in the mouse, and I've got one of these rather nifty mouse adapters which lets you use modern-ish mice. I say modern-ish because they still have to be a little PS2 mouse. And what happened was this Gotek unit here isn't bolted down because I got this Atari ST from somebody and it didn't have any screws in it. So what happened, I turned it upside down and when I flipped it back, it seemed this had moved and that had caused it to damage some of this circuitry here. And this circuitry, I think, is responsible for the color sync. It's definitely to do with PAL systems, and there's a 4 megahertz crystal and some conditioning things. And what I've learned from doing this is that these are used to go all the way to the blitter chip, which is, oh, right here, sorry, that's the main processor. The blitter chip, which is here, which is being run off the 32 megahertz clock and its circuitry, and it divides down all of the other clocks apart from, well, this clock, and this clock, which are doing their own thing. And then what it does, it sends an H-sync pulse back up to this circuit, which in turn then affects this circuit. So it's all to do with keeping the PAL frequencies in check, so like a phase lock loop or something like that. So basically when I tried to turn on my ST, I was getting nothing on the screen. It was just a blank screen. And then what was happening is this light would come on, which is the power light, and the drive light would not come on. So that's the biggest symptom. So if you've got that going on, then that's how you know you've got I say a similar issue. It could be anything, really anything that's stopping this from running. So what I did is I got out my oscilloscope and my logic probe and my multimeter, all of the usual things, and then through determining those that I had no clocks running here. So if you look at the CPU, you'll be able to get the pin out of that. You'll see there's no clock input to that. There'll be no clock input to this. And if there's no clock input for this, there's no clock inputs for virtually anything else. If you want to check your other clocks, there's a few good test points, and I'll point them out as best I can. So this U306 guy here, U306, you want to see if there's anything on this pin, which is the fourth pin along. If you have a small signal there, that's your H-sync signal. That means your main clock here is actually running, and that's a good sign. Also, of course, you can measure this without disrupting it too much and see a 4 megahertz from there, well, 4.4, and then you've got the 2.4 crystal. I like to measure it from here. Where are we? Here we go. I like to measure it from there, that pin there. You can just see it's the one where it's connected straight down. So really try to start isolating these. To cut a long story short, I basically replaced a bunch of these, and I'll show you them on the screen. And then I replaced a bunch of these. And as it turned out, one of the replacements was faulty. And I'll show it to you right there. There's the replacement. You can see actually one of the legs fell off. But that only fell off after I was testing it with my component tester and saying it's behaving like a diode. So that's how I eventually discovered that fault, but not before I got out my other Atari ST and started comparing the two. So I learned a lot about the functionality of this one by comparing the functionality of that one. And you can see, if you've been following my tweets on the subject, I did use a thermal infrared camera, wherever that might be, and took some photos and checked the boards in operation. So all in all though, just as a quick summary, it's unplugged, so don't worry, I won't zap myself, but the Atari ST power supply is a very robust unit. You can test it separately by taking this connector out. You don't even have to take the shielding out to get to it. And you should see the two red wires. You should get 5 volts on those if you compare the red wires to the black wires. And if you compare the black wire to the blue wire, that should say 12 volts. And if you've got clean 5, clean 12, it's good. If it's a bit low, you can use this little pot here to turn it up. Be careful, very slowly and carefully. Watch out, there is live electricity, and use a meter when you're doing it before you hook it back on. I think you're allowed a leeway of a few percent, so if it's sort of like 5.1, 5.2 or something, that's probably going to be all right, give you a little bit extra headroom. And then if you take out the power supply, you can see it's quite a nice standard module, and that's a newer model. So this is a newer model Atari ST here. And then if I move the camera over, you can see an older model. And the power supplies are slightly different, but they're all essentially the same. This one doesn't seem to have an adjuster on it that I can see anyway. No, it doesn't have an adjuster on it. And that's the fuse. So again, don't do what I just did and touch that if it was live, because that would blow your finger away. But if you think your power supply's gone pop, it's probably that fuse. There's a few power caps on these power supplies. I do hear the power supply caps can go, but in all honesty, well, they look pretty good, to be honest with you. I'm not going to touch those. From a 1991 marked machine, they look absolutely fine. I think Atari actually did use pretty good quality caps, because looking at the board here, all of them look really good. I've seen nasty caps. These are not nasty caps. In fact, I think the hardware has been really nice to work with. The PCB hasn't tried to delaminate itself or poop the bed in any way. Now, once you've got all of your shielding off, though, and you're down to this stage, there are a few things I would recommend you might as well do. If you've always fancied a TOS upgrade, it's a good opportunity to do it. I was really lucky in this machine because it's actually got sockets right there. And there's a previous video, if you look at my video playlist for Atari ST, it allowed me to put in the new chips here, which I think were a bit bigger. And I just had to change some jumpers. I had to add a jumper here, and I think I moved these wire links. I mean, these look like resistors, but they're just basically 0 ohm resistors in there. If you've got one of the older models, you can see you've got a little bit more of fun and games, because you'll have to remove these chips. But if you do remove them, make sure you put sockets down. Some other notable difference between the two machines, interestingly, you can see you've got your main processor here, and you've got your blitter here, and then there's this weird empty, it's not a footprint anymore, they've deleted a part here. And you can see on this one, you've actually got, again, your processor here that's socketed, your blitter here, that it actually looks like it's twisted as well. I don't think pin 1 is in the same place. It's just marked slightly differently than this one, whose writing is that way. This one's writing that way for some reason. But yeah, you've got this other chip, which I guess was incorporated into some of the other chips, probably this one. And underneath, I think they're pretty much the same, but just socketed. And then also here, the floppy disk controller is socketed, whereas on the old one, it's soldered to the board. But then this bit here, which is the Yamaha sound chip, is in a socket. And then on the new one, they've bolted it to the board. So it's weird. It's like, by this stage, they know what chips are going to fail and what aren't going to fail. So it does seem to be the ones that you're going to look out for are the floppy disk controllers and the TOS chips. The rest, they were like, nah, they're good enough. This one's got 4 1 meg memory chips in it, and this one has got 4 256K to give it the 1 megabyte. So it's kind of a shame. I kind of wish I had some chips now, but I could just, because I've got to reassemble both of these machines, I could put that one back together with it. So yeah, interesting tools to use. I would say a lot of people say to use a logic probe. I didn't get much use out of a logic probe on this project, so I would, if you haven't got one, they're cheap. So yeah, get one that's cheap. It might not help you with this though too much. If you really want to invest in a good DSO. You can get 2-channel DSOs with a, I think, 60 hertz. Am I thinking that right? 100 meg, 1 gig. Yeah, 60 megahertz for like £200. I know it sounds like a lot of money, but if you've got this sort of machine or plenty of them, you'll get a lot of use out of that. I've got a few. Just there's some of my collection sitting on the shelf there. They certainly exercise this gadget. I don't think you're going to get much joy without some sort of scope. I know you can get some pocket ones from China. They may be fast enough for you. The other thing that's really useful is this type of component tester where you put the thing in and hit the button. You can see I've soldered some probes on here, but they don't work. So I think it's because it's that tiny thin Kynar I used. We'll be getting rid of that. Ignore that. But yeah, this thing's cool. It'll tell you anything about the components. In fact, I've got one here, which is one of the transistors. Atari seem to have used a lot of the same transistor, which is pretty cool. So you can, I bought a job lot basically of 20 of those, and you can see there NPN transistor and all the gubbins. Isn't that nice? It even tells you which is the base, emitter and collector on the pinouts, because of course some are the other way around. So some have the collector on pin 1 and the emitter on pin 3. Always just a gotcha, of course, when you're testing. Any other things to note? Oh yes, I did use a FLIR, and I don't know where that is. It's probably hidden among my bits. You can see it's not very well suited in here for this kind of work. It's again something I would have put down, but that gave me a thermal profile of the boards. I'll put some on the screen now so you can see what that looks like. That can help because you can see for hot components on there. If it's something too hot, it's probably having a problem. So that's what you can use to identify. And something else that's really useful, of course, I've been using this little battery USB soldering iron. I mean, that's been invaluable. I'm in the front office here. I don't have any, tools other than what I just drag in here. So that's all I needed to do this board pretty much. I mean, I did take it to the back office every now and then just to get it under the lights, but really that soldering iron all you need. So to summarize, oscilloscope if you can afford one, soldering iron, your meter, your tester, and I'm going to assume you've got a voltmeter, because really, if you haven't got a voltmeter, just get one. They're like literally £3 on eBay. You just need a voltmeter in your life anyway for any of this stuff. You'll be able to get going. And the conclusion for all of this is that it does work. I'll show you it working on the end of the video. And it's very satisfying to know that you've saved your Atari ST. And for me, this is my daily driver workhorse Atari ST, so it gives me an amazing sense of satisfaction to be able to keep using that, even though it was kind of inconvenient for it to break when it did. Oh yeah, here's an interesting thing as well I've observed. All of this circuitry here though, if you think it's messing around, because you're not getting this clock or some of this stuff's messing around, what I later discovered was if you take a probe, you just make a double-ended probe like that, you can get these clips off eBay or somewhere, and you go to this negative, this is ground basically, and you can see a component there called R121, right there, that resistor. If you tie that on there, boom, effectively what it will do, I know, there we go. Took a few goes. Effectively what it does is take all of that out of circuit. So this 32 megs will just run unencumbered by any kind of signals from that. So that might mess up your RF or composite output, but it's okay for RGB. So it's a good little test really. If you think that's messing things up, you can hook that on and power it up and then just see if your drive light comes on. And really, if your drive light doesn't come on, it's not working. You don't have to, it's really nice to test because you turn it on, you don't see a yellow light come on within a few seconds, then that's it. This guy isn't working, or this guy isn't working, one or the other. And if this doesn't start, basically if this doesn't start, this will not start, and if it doesn't start, nothing is really working properly. You see some of the components getting warm, they're kind of doing their own thing a little bit, but without these two to coordinate the whole thing, it's not going to work. So thank you so much for watching this video. I know it's not my usual kind. Oh, there we go. But I just wanted to get some documentation out on this thing, because again it said it was unplanned, and I just wanted to make sure the world knew you could do this. And really all you need is these schematics. You can just fetch them up off the internet. I'll put a link down below if I remember, and it's a really good, it's the Atari ST schematic, and it just tells you everything you need to know. And I'm sure if you have an FM or one of the other models, you'll get the schematics for those as well. You will learn to follow it, trust me. It's pretty darn easy. I mean, you can see I've just been highlighting the sections that were relevant to that. So this whole thing here, I'll tell you, this whole section here, which is all the problem area right now, really is just these few components here and this down here. And the fact they're all in one place on this drawing, some of them are actually here and some of them are down there. It's quite interesting. They're sort of split. There's one line that comes through this R20 that goes and that's the feed that gets this guy going. So yeah, you can just go through the whole Atari ST schematics. I don't know how many pages are there. It's not many. It's less than 10. you can just digest it, understand and learn everything about it. And once you get sorted with this bit, which I think is probably one of the most complicated things on the whole board because it's all to do with the fancy timings, everything else becomes digital. Everything else becomes something you can do with a Logic Pro. So there, hopefully that's some use to you. Again, as per usual, please come and chat to me on Discord if you want to chat. If you want to buy me a coffee, go on Patreon. I've taken away most of the Patreon tiers. I kind of don't believe in them anymore because I think it's up to you. You decide what you want to do. If you want to be a patron, go in at $1, go in at 10, go in at 2, whatever you feel. So thanks very much, guys. As ever, thanks for watching.